Well, hello, and here we are in season 4, episode 7. This will be part 2 of Biomimetic dental materials. And so, when we talk about dental materials being biomimetic, we want something that has the ability to make the tooth act like a regular tooth. So, a regular tooth that doesn't have any restoration, it still has forces that makes it bend and flex. And the tooth naturally has the ability to stay connected. And so a natural tooth has a cohesive strength, a tensile strength, and that's measured by engineers. And these cohesive strengths and tensile strengths are the criteria that we use, along with one other consideration, which is called modulus of elasticity, which is the stiffness which gives the tooth its characteristic of being able to not collapse under biting forces. And so the first concept of a tooth being connected to itself with tensile strength or cohesive strength is very critical for the dental bonding systems that we use. And the dental bonding systems have evolved over the last 40 years. And so we know very specifically if you bond to a flat surface, what the bond strength will be to that flat surface. But then we had an evolution in the testing of these bondings also to include cavities that weren't flat. And that's an important consideration because a material can have very high bond strengths on a flat surface, and those bond strengths may be compromised if the shape or the configuration of the preparation is different than flat, which usually it is. But a dental bonding system that has been tried for over 30 years, for example, Optibond FL has been tried for over 30 years, and SE Bond has been tried for over 30 years. And then other materials that are similar to Optibond FL or to SE Bond, like SE Protect, has now been tried for over 15 years, close to 20 years actually. And so the longevity of these tests, where they are tried, tested at 24 hours, and then restored and then tested again at 1 year or even longer in a few cases, give us an idea that these bonding systems, certain ones of them, have better chemistry and create better hybrid layers. And so the world's master of all masters of testing dental bonding systems, that would be Bart van Meerbeek and his team at Catholic University in Leuven, Belgium, have given us a phrase that has been challenged but without a good foundation that we call the gold standard of strength and durability in vitro tests and in some in vivo tests. So an in vitro test doesn't have a hydrated pulp, an in vivo test does. It could be done on animals or on human beings. But once a clinical trial comes with actual dental patients and long-term results come, then that is the real foundation for saying this is a material that in clinical situations can be very effective. Now, a very important article came out in 2007, which is now 20 years old. That's a long time. And this is the article. Just happened to have a copy. And so Dr. Akimoto, who is the main author of this, said this is a 10-year clinical evaluation of a self-etching adhesive system. So they covered many teeth, 87 teeth in 42 patients over a period of 10 years. And the bonding system that they were evaluating is called Liner Bond 2. And Liner Bond 2 was the first self-etching system that was developed by Cuore Company. It was a 2-bottle system, and the chemistry was revealed in the articles that were published. And so the exact monomers, the exact solvents, monomers that were both part of the primer or part of the adhesive were disclosed. The exact recipe that was used obviously is there, but to cook something, you have to have more than the ingredients. You actually have to have pans and knives and spoons and a stove that has consistent heat. I mean, I've done a little bit of baking, a little bit of cooking in my life. I'm going to be doing more as my wife is depending more on me with my expertise. But the idea is that if you have a quality control in your manufacturing, that is huge. But it's an investment that companies need to make. And I've seen companies that have quality control of 2 scientists or 2 engineers, and I've seen companies that have had 40. Maybe 40 is an overkill, but if you have a successful product, then why compromise on what you've been doing that's been successful? And this is the situation of these gold standard products. This Liner Bond 2 showed no sensitivity in teeth over 10 years. Sensitivity on composite restorations has always been an issue from the very beginning. What did the sensitivity come from? Martin Brandstrom showed that in 1982, published an important paper in 1986 showing that it's the pulpal fluid movement that accumulates under a restoration that forms a gap when the polymerization shrinkage of the restoration pulls it away from the tooth and the hybrid layer that is trying to integrate it. So Martin Brandstrom in the 80s was testing materials, early materials that were forerunners to Liner Bond 2, but they had very different characteristics. They were chemical cure materials, and they had different monomers and different mixtures of solvents. And each bonding system has its own recipe and, again, its own quality control. But Martin Brandstrom saw that these early bonding products to dentin didn't stay bonded. If you have something that you think is happening, but it's not happening in a live patient or an in vivo study, for example, then you have to reevaluate what the claims were of the original introduction of that product. And that feedback can come in many forms, but probably the best form is on what's called a practice-based research network. So what is a practice-based research network that could evaluate a material to see if it's biomimetic, if it acts like a natural tooth? How long does a natural tooth last without breaking in half? Pretty much 100% of them do. But if they have fillings in, then we have a whole different condition. The evaluations need to come from actual dentists that are using these materials in dental treatment. So this practice-based research network that I've created is about 100 very close dentists that have been trained very closely with me and have known me for over 30 years. The second level of a biomimetic research network, or the practice-based research network that's part of the Alleman Center, are the doctors that we've trained in the last 5 years or 6 years now that have a higher degree of scientific foundation. And they, again, have the ways to feedback to me, give information to me through telephone. That's the first way, the only technology was available 30 years ago. But then we had emails, and then we have Instagram, and now we have groups that are called WhatsApp groups. But all of these communications are very important, because if I say, this is the protocol, do this, then do this, look for this, look for this, look for that. With photography, you can see exactly what condition the tooth is at each step of the restorative process. We teach that the 6 lessons approach, or any biomimetic approach, really is a bottom to top approach, meaning what you do to connect your restorative materials to the tooth is the most important step, and that's conditioned upon how the tooth is conditioned with diagnosis of caries or cracks underneath that immediate hybrid layer from the immediate dentin sealing. But when you control for all of these and you have the same conversations with dentists who have been trained in the same protocol, then you have a very strong feedback mechanism for saying, if you do this, you'll get this result. And that's what we have in the Alleman Center. And as far as I know, it's the strongest practice-based research network that's ever been established. But this practice-based research network, Tokyo Medical and Dental University also has that established among their faculty and the students that they've trained. And this is the patient base that was used by Akimoto to find this 10-year success with the beginning of a gold standard bonding system. But by 1998, the final recipe or the final composition of the gold standard bonding system, SE Bond, was in place and has been in place ever since 1998. Well over 25 years. Bonding systems with their specific compositions or recipes need to be judged individually. And there have been many attempts to say, well, these bonding systems are the first generation, these bonding systems are the second generation, these bonding systems are the third generation, the fourth generation, the fifth generation, the sixth generations. And people that have been classifying these bonding generations have been doing it and still do it, but it doesn't mean anything because you can have something that is similar and not the same. And if it's a proprietary mixture and a proprietary quality control, then somebody who's trying to copy another bonding system is going to have difficulty making those conclusions. And so that's the one thing that most dentists have no idea of how patents are established, how long patents are in place, and how patent violation is just a way of life for most manufacturing companies. They, if we steal your information, then sue us. I mean, I hate to be cynical, but that happens in the computer world, and the airline world, and the dental world, and a lot of lawyers think that's just fine. It's job security for them. But in a regular practice, you don't have time to evaluate everything that I have had time to evaluate, or that Dr. Akimoto had time to evaluate, or Charlie Cox had time to evaluate, or Dave Pashley had time to evaluate. That was their university position, and they left a body of work that now is into thousands of articles that have been published. They give you information about each bonding system. I was once commissioned by a journal to evaluate current bonding systems. I went to the Henry Schein catalog, and on that particular day, there were 66 bonding systems that were available for purchase from Henry Schein. 66. Now, I personally knew that the ones who had been established as gold standards, how they were invented, how they were marketed, and who did the inventions, who were the chemists, and how they have stood up in our practice-based research network. But I also knew that other companies had been making bonding systems that they did not sell under their own name, but they were selling them under another name. They were making a bonding system, but this other company was selling it as their bonding system. That's called a knockoff. But the idea is that these bonding systems have to be judged on their own terms. You need to know not what generation it is, but exactly what system it is and what is the actual composition and how they are applied. And another concept that is not understood well by dentists is that if you do not have a systematic way to establish a caries endpoint, or if you do not have a systematic way to diagnose and remove cracks, you are going to have a percentage of failures that will kill pulps and a percentage of failures that will take the tooth out permanently, which we call a catastrophic failure. And so to talk about a bonding system without talking about these other considerations just doesn't make sense. But the consideration that should be tested for with every bonding system, but is not, is what we call C factor. And so the configuration or the shape of the preparation that the bonding system is tested on makes all the difference on the strength of the bond that you're going to have. But there's a consideration that even if you make a preparation that has 4 walls instead of a flat surface, you know that if you bulk fill that, you'll lose 80% of your bond strength. If you use 2 2-millimeter increments, then you lose 50% of your bond strength. Well, if you have a system or a technique or a protocol that doesn't allow that to happen, then that is a biomimetic protocol. And the biomimetic protocols that we have include the use of a flowable composite. After your bonding system, the flowable composite, there are different configurations, or I should say compositions of flowable composite, but we have tested 3 over long terms, and those 3 flowable composites have all had the same results. But the 3 composites have different characteristics. For example, the first composite that was tested vigorously was the first flowable composite that was ever made in the world, and it's called Protect Liner F, made by Coire. It had one really great characteristic. It was microfilled, which made it have a different bondability to the adhesive layer that it had to the overlying composite. So that created what's called a fail-safe, or a secure bond characteristic of a restoration. But the drawback it had was huge. It was radiolucent. They didn't put any material that would make it radio-opaque. So all these restorations looked like there was a gap underneath the composite, which had a radio opacity, and the liner. The reason they did this is because the original composite they used didn't have radio opacity either. And so all of these early adhesive restorations from Japan, they just looked invisible. You couldn't see them. Because amalgam, you see like white, composite, nothing, but they weren't thinking down the road, and it became a problem in the United States. So Protect Liner F was never used in the United States. But the characteristic of a microfill rather than a microhybrid or a hybrid flowable composite had different relationships to a failure mode. And so this was investigated many times. And so we were able to find a microfill flowable, and that microfill flowable was a material that we used for 6 years. And then it was a little bit radio opaque, but not a lot radio opaque, but it had a higher flexibility. So the modulus of elasticity was not quite like Dentin. It had about a 6 gigapascal modulus of elasticity, which was about the same as the Protect Liner F. But then the second composite came from Courret after Protect Liner F was a composite called Majesty Flow. And this Majesty Flow had everything. It had radio opacity. It was even a smaller filler particle than the microfilled. It was a nanofilled particle, and it had a higher composition as far as volume and weight. And so it acted like a restorative composite, but it had enough flowability to make it easy to make a uniform layer, and it wasn't too thick. It had perfect characteristics, still does. Voco has copied that after the patent expired, and so you can get a flowable composite, has the same increased weight, and it has a nanofiller characteristics. So we recommend that also as a biomimetic resin coating. And so this idea of establishing a gold standard for your immediate detent sealing, establishing a gold standard for your resin coating, we've done this successfully. And now we have another material that we use in a biomimetic restoration in that first millimeter of restoration in the resin coating, which is fiber placement. And that was introduced as a biomimetic material early on as a fracture stopping characteristic under a restoration. That was published in 2004. And so we use Rib-On for that characteristic. So you can use a composite onlay that may fracture, but it will not fracture through the Rib-On. That's a very, very nice fail-safe characteristic that we've been teaching since 2004. But then the stress reduction of the hybrid layer formation by using Rib-On, because now we know that the Rib-On has the ability to take any overlaying stress of polymerization, and it's absorbed in the separation of the fiber. And it never gets communicated to that immediate detent sealing layer. And so the hybrid layer is never compromised if you have a layer of fiber between overlaying layers of composite. And so that's a fantastic approach in the area close to the pulp, where you're not depending on the very high strength, the cohesive strength of the bonding system. You don't need high cohesive strengths in a natural tooth in the middle of the tooth. You only need those on the outside. And so a tooth is hollow in the middle, the cohesive strength is non-existent, but the cohesive strength of the tooth itself comes from this connection around the pulp. And so the tooth is connected side to side, front to back, and top to bottom by this outer shell of highly bonded dentin and enamel, DEJ. And this is what we're mimicking in a natural tooth. And so we have fiber for stress relief and fracture resistance. We have resin coating for a secure bond strategy or a fail-safe strategy. It also takes a little bit of time to place the resin coating, so that's part of our protocol, which we call decoupling with time, which is very important, a time to allow the hybrid layer to mature. We've got our gold standard bonding systems. I think I told you about the 60 bonding systems I evaluated. In the world, there's been over 100 created in the last 40 years, but you can get some very inexpensive ones made in China. Who knows what's in those? That's, I got to tell you, we have doctor from Burma, from Myanmar, who, you buy a $400 gold standard bonding system or a $4 bonding system from China. I don't know, maybe they're just giving away. It happens, but we don't have good information on many of the 100 bonding systems that have been created. So I guess we'll do a materials part 3. We've done part 1, part 2. Next time we'll just talk a little bit about liners and bases. And we'll also throw in a little MTA and maybe a little more on zirconia. But till next time, get bonded, stay bonded.